Okay, so use substitution is kind of one of those thorns in the flesh in AB calc, right? Kind of confuses people right off the bat. So basically you're using derivatives to solve integrals, okay? And you're going to see this again in integration by parts, so you might want to kind of get used to it. And hopefully we can kind of smooth out any rough edges that you have on it this year. So you're looking at something like this. Okay. This is basically the chain rule for substitution, or for integration, right? We're just working backwards. All right. So when you're looking at a problem like this, what you notice is that, what's the derivative of x cubed? Right. So if you see a situation like that, that's where you're going to use substitution.
Will it always be like that?
It won't be. Sometimes it's not perfect, right? So you have to manipulate a little bit. But in general, if you see the derivative, the variable is the important part, right? You can mess with the constants, but the variable is the important part. So in this case, we are going to set u equal to that right there. Okay. And then differentiate. So what I've done is I'm going to replace these two with that now, right? And then u is x cubed, right? So and then that's actually du. Right, so we've gotten rid of this whole mess right here and put du in, and we've put u in for x cubed, right? Okay, and can you integrate that pretty easily? Yeah, what's the integral of sine, or antiderivative of sine? Cosine. Are we done yet? Yeah, we do need to replace this back in, so it would be negative cosine x cubed, right? So, again, look for derivatives and then stay organized. A lot of people get messy and it confuses
so
things.
where's the 3x squared dx now go?
You don't need it. Because it's the so if I differentiate this, go ahead, Wyatt. You were gonna explain it.
When you derive that, it's chain rule. Do you drop the 3x squared on the outside?
Yeah.
Right. So I think you got it. Right. Sign it. Derivative outside, copy inside, and then the derivative of the inside, right? So if you always want to check your work, you can always refer back to the original derivative versus antiderivative. Okay. Thinking in terms of the chain rule there, right? Okay. Let's see here. Do you need to see another one like that, or you think you can do those? Let me show you one more.
Are there more complicated versions of it?
There are, yeah, I wonder if it's that.
Because like that one seemed fairly easy, but I thought maybe it would be like picking up to substitute, but
Okay, here's one where it's not painfully obvious. Okay, you don't need to use substitution for this, but you can use it. What am I going to set u equal to? Because what's the derivative of that? 7, right? Is there a 7 out here? Not really. So it's going to kind of mess with things a little bit, but one way that I showed you last year was to deal with this by dividing by the derivative. Do you remember that? Okay, so that's one option. You don't remember that? Okay, so this is u substitution shortcut, right? Because there's only a numeric derivative here. If you just divide by that, you've got your answer. Okay. Wait, that's something's not right there. So it'd be derivatives, negative cosine, right? So when you integrate, sorry, now I'm on track, divide by 7. Okay, that's what we did last year. Okay, or you can use u substitution to differentiate, right? But there's no 7 here, correct? Correct. So now we have to divide this out and get 1/7. Okay, and substitute. So we'll have the integral 1/7 sine u du. That's where that divide by 7 comes by in the shortcut. And you could finish that, right? So, same answer. Okay, so just a little same deal. There is an example of u dx. Here's one where you have to actually do it twice, I think. Let me show you that one. What are you tempted to set u equal to here? Okay. So du is 5 dx. Okay, now here's the problem. Right now, 1/5, right? Have we taken care of that?
No.
We have not. You can put it outside. It doesn't matter. Yeah. So what he asked was that perfectly legal. Keeps it cleaner if you want. So we have not dealt with this x, right? The question is, how would we? Is there somewhere from what we defined u to be that we can get x and substitute it? Can we get,
for x right there.
yeah, exactly. So we would subtract 1 and divide by 5, right? So we have now we can substitute that in here for x. That's the additional step, right? So sometimes you won't get the exact match you're looking for there, but you can still manipulate this to substitute. Do you want me to rewrite that? Now, how are we gonna deal with this? Oh, can I take a 1/5 out again? Okay, let's do that, 1/25, right? I don't have a product rule for integrals, but how can I simplify this? What'd you say, Wyatt?
That's you can take out of U.
Take out of U?
Oh, no.
Wait, I thought you took out the 1/5.
We did.
Okay, so then.
So it's U minus 1 now, right? So we still have U minus 1, U to the 1/2. Can I simplify that algebraically to make it an integral I can solve?
Could you just take the 1 to 1/2?
Hippity hoppity property. Yay. Right, so this would be now U to the 3/2 minus U to the 1/2. Correct? Yeah. Now that's an integral we can handle pretty easily with the power rule.
Why did the fact that they multiply by the
You took a 1/5 out. 1/5 times 1/5 is 1/25. So, yeah, lots of extra little algebra things in there, right? Yeah, gross. Some foods taste gross, but I don't know if math can be gross. Nice try though. Okay, so we can finish that, right? You good there? Okay.
What if math such as this gives the taste of bile in our mouth, therefore it can be gross?
Not that tastes gross.
Yeah, the sensation that it brings to the body. Yeah.
Let's try some that are, those, so we've done all indefinite integrals so far. Let's try one with it's a definite integral.
Yeah.
You sound so excited.
Static.
You are ecstatic. It just adds one step to deal with those integrin limits. Right, so what's our U value? Yeah. And the derivative is, and there's no 3, right? So move this over. All right. So we have the integral of 1/3 root U du, right?
Sure.
X squared dx, x squared dx, those are gone, right? Eliminate, eliminate, and then this right there. Substitution. What do I do to get my new integral limits? Because I can leave it like this and solve it.
You just plug the value.
Plug x squared back in, 3x squared back in and do it, or I can just transfer these into u. So if x is 0, u is 1, right? And if x is 2, 9. Now I don't have to worry about putting x back in there, right? So my integral is 2/3 u to the 3/2. Is that right? So that's 1/2, add 1, divide by, yeah. And you could probably finish it from there. But if you change these, do not put the x back in here. Okay, this is an easier method, I think, but just be
And
careful.
then when you go to solve that, you plug
So,
4x cubed plus 1.
2 ninths,
No.
we'll have 9 to the 3/2. minus 1 to the 3/2. That's it. Don't mess with x anymore because you transferred everything into terms of u. Okay. It usually simplifies the arithmetic at the end if you do this method. If you don't do it, you're going to have like x cubed plus 1 in here with this root in it as well, the exponent. So I'd just transfer it. You know how to solve that, right? You leave it because it's a free response question. Okay, what's the square root of 9? 3 and 3 cubed is 27 minus 1. So just a quick reminder on arithmetic there. Okay, and I know you can do the rest of that. All right, so that's u substitution. Again, recognize derivative, solve integral. All right. We good? I hope so. Because I'm done. Hopefully does it make more sense than it did last year?
Yeah.
Yeah.
Okay. You guys are just, it's amazing how you can let things rest in your mind and then come back to it and you're like, that wasn't that hard.
I feel like this lesson last year was double.
Yeah, we did this in 2 days.
I did not like you stuff like at all.
No, none of you did.
The problem I had with it was I didn't know what to do with the number.
Why? He probably could do this stuff really easily. It's all the fancy notation that makes it look correct.
It was,
U's and x's and derivatives with integrals and this and that and the other and
and I told him, like, I don't know what that means, so,